Hello everyone, welcome again in Eng-Man YouTube channel. So we go back to HYSYS video regarding CO2 properties. As you can see, previously I have some doubts regarding the density prediction. So if I click create stream analysis and I go to property table, I say that I still have doubts with this. Okay. Yeah, and then I want to convert it to kilogram per meter cube. So I go to unit settings and then I double click the mass density. So 1 pound per cubic feet. Oh, I misunderstand the message here. So actually 1 pound per cubic foot divided by this thing is kilogram per meter cube. Okay, so this one divided by this one is kilogram per meter cube. And this one is very small. Okay, so actually 1 pound per cubic foot is, yeah, it's a big number and we will calculate that in spreadsheet. Okay, so by the way, you can directly change it to international standard unit. Now you see the unit is in kilogram per meter cube. Click OK. Now I go to property table again, and now my mass density is in kilogram per meter cube, and now it is much more makes sense. All right, liquid density 600, more than 600 kilogram per meter cube. It's much more makes sense. And the temperature is now in Celsius and pressure in kilopascal. Okay, so it's much more makes sense. I can right click, select all, copy, and then I will paste it on my spreadsheet. And let's go to my spreadsheet. Okay, so I will paste the table here. So yeah. Now the temperature in Celsius, pressure in kilopascal, phase, but now it's in kilogram per meter cube. Okay. And then I will check the unit setting again. So the statement is like this: 1 pound per cubic foot, like this. So it should be divided by this number. It will be equals to 1 kilogram per meter cube, like this, right? So actually anything here should be divided by this one. So not multiplied, but divided. So if I divide with this one, so now the values are perfectly the same with this one in standard unit. Okay, so now I get my mass density as a function of pressure. Here, I get the results in points, but I can also generate the correlation using regression, using trend lining in my Excel spreadsheet. So I get this function. Okay. And I will copy the picture and then go to embal, for example, here. So now the mass density is 2E, like this, multiplied by pressure, powered by 5. Let's be careful here. And then minus 2E minus 12 multiplied by pressure to the power of 4, and then plus 4e minus 9 multiplied by pressure to the power of 3 minus 3e minus 6 multiplied by pressure squared plus 0.0013 multiplied by this pressure minus 0.0454. Yeah, it's just issue regarding the comma and dot for the separation of decimal numbers and thousands. So it's quite troublesome, but you get my message, right? Later on, I will change the setting. Okay, so by the way, you can calculate the density of CO2 at some pressures using this correlation that you can generate from the results from HYSYS. So I think that's all. I will, of course, finish this calculation. So thank you so much for watching and see you again in the next HYSYS videos. Thank you.